Hello everyone, in today's lesson we are going to take a look at some applications of systems of linear equations. As always, I listed the strategies that we can follow to solve such problems, and I would like to actually go over the strategies as we solve a problem. There are two groups of questions we're going to talk about today: word problems with basic numbers and word problems with money. Don't worry, I'll give you an opportunity to practice on your own as I go over the lesson. So the first problem says that the sum of two numbers is 176 and their difference is 48. We need to find the two numbers. Remember that when we solve linear systems, we actually deal with two variables, the variables x and y. That's what we use in general. And the very first step would be assign two variables based on what you're required to find out. And think about it, what are we required to find out here? We are required to find the two numbers, okay? So because we're trying to find two numbers, then we're going to say let the first number be x, the second y. Because this is a simple, straightforward problem, I am just going to write a single let statement. Let the numbers be x and y, which is short for let the numbers be represented by the variables x and y. And then I read the problem for a second time and I pay more attention to connections between x and y as described in it. And it says in here that the sum of the two numbers is 176. So if the sum of two numbers is 176, that means that the two numbers x and y must add up to 176. The next piece of information given here is that the difference of the two numbers is 48, and because we aren't told which number it comes first, and it doesn't really matter when you think about it, then I'm going to write x minus y equals 48. Okay, this is called translating words into equations. So what we just did in here was recording the information that we know and the information that we don't know. Usually we want to make a chart, but in this case we don't have to. And then write a system of equations, which we were able to do right away because it is a very straightforward question. In the next step, we have to solve the system of equations. So let's get started. So to solve the system of equations, I would use elimination because, it's not a secret anymore. It is my favorite method. And as I solve by using elimination, I'm thinking, which variable do I want to eliminate first? And I see that if I added the two equations, then I could easily eliminate y. So I will do that. So I will write here x plus x plus y plus negative y equals 176 plus 48. Oops. Let's keep our color coding like in perfect order. And now we're going to simplify this equation, and we will get x plus x to x. The y terms will simplify, and then we have 176 plus 48, which is 224. So isolate x from the coefficient 2, and that's done by dividing both sides by 2, and we got our first number, 112. So with this, we have only found the answer for the first number, but we have two numbers we need to figure out. So we just found x, we need to figure out what y is. In order to find y, we can use either the first or the second equation, obviously. So I am going to go with the first equation in this case, and I will rewrite it as is for now. It's not a must-do step. I'm only showing all my steps in here because I'm explaining it. And then substitute x by 112 plus y equals 176. So y equals 176 minus 112. And then y equals, let me do this in my head, 7 plus 1, 6. So I'm going to say 64. So we're going to say that, hey, we're all set with y. Remember what x and y represented? They represented the two numbers. And we're going to say that we got both of them, which means that we're ready to write the therefore statement. Remember the therefore statement, right? So we're going to say that the two numbers are 112 and 64. You're probably wondering, hey, what would have happened if we subtracted y minus x in here instead of x minus y? Would you get the same answers? Well, if you would like to, try and see. So what you're gonna get. But my guess will be that you will get the exact same numbers, but you will find them in different orders. Now, in the next example, we have Luke's age 2 less than twice Peter's age. The sum of their ages is 37. And we want to let L represent Luke's age and P Peter's age. And we wish to know their ages. So we have to write a system of equations to model this situation. At this point in time, I would encourage you to just pause the video and try to do this on your own. Remember that when you are solving word problems, you have to read the problem just in general for the first time. Do not stress out too much and think that, oh, I have to understand, I have to solve, and I have to come up with a solution right away. Just read it as if you're reading a story. So you are trying to know what the story or learn what the story is about in this word problem, okay? And then when you read it the second time, I promise that things will make a little bit more sense. So here we got Luke and age and Peter, goodness. So we're going to say Luke's age is L and Peter's age is P. So these are our two unknowns. Now, if the sum of their ages is 37, so if you translate these words into an equation, then we would say that Luke plus Peter equals 37. Now, there is another relationship described between their ages, and it says here that Luke's age is 2 less than twice Peter's age. Now remember that twice Peter's age must be 2p. And Luke's age is just L. So now we have a variable for each age, and we have to try to put it into an expression or equation. So Luke's age is 2 less than twice Peter's age. So less is the key word, which means that Luke is younger, which means again that twice Peter's age take away 2 will be Luke's age. And then we're going to say we have our system ready to go, and we can solve the system of equations. Now, in this particular question, we are not asked to find their ages. The only question asked in this case is to write a system of equations to model the situation. We're going to take it a step further and obviously solve the system. Remember that when I use elimination, again, I'm going back to my favorite method, we need to line up the variables. So as you see here, the variables aren't lined up. We have L and P here, P and constant, constant and L. So I will rewrite the first equation as is. So L plus P equals 37. And I will match the terms of the second equation to the terms of the first equation, which means that I'm going to start with the term L in the left side of the equation, which means L is changing to a negative, so negative L. The next term must be the P term, so 2P is already in the left side of the equation, so no need to change that, so plus 2P. And the number negative 2 is in the right side. We want to bring it on the left side. We want to bring it to the right side, and we'll do so right away. Remember, because it's switching sides, it must switch sign as well. And now I'm going to think, which variable do I want to eliminate? Remember, the strategy here will be, do they have same or opposite coefficients, or any of the variables? Well, these two have same sign, different values, and these two are opposite coefficients, so it would be easier to eliminate L. And we remember again that when the two coefficients are exact opposites of each other, we need to add the equations in order to simplify, and that's what we'll do. Here we go again. We're going to have L plus negative L plus P plus 2P equals 37, and then plus 2. Let's solve this very simple linear equation. So these two terms simplify, and we end up with 3P equals 37 plus 2, 39. So P is 39 divided by 3. And that will make Peter only 13 years old. There we go, Peter. And now we're going to move on to Luke's age. We know that Luke and Peter together make 37. I write the equation as is first, and then Luke is unknown. Peter we know now, not a mystery. He's 13 years old, and that's 37. So L equals 37 minus 13. That will make Luke 37 minus 13, or 24 years old. So we're ready now to state our final statement. We're going to say that Luke is 24 years old. Okay, and Peter is 13 years old. Wow, he must be like in grade 8, 9, right? Okay, so moving on to the next example, we're going to take a look at an example with money. Again, as I mentioned before, we just read the problem just for fun, to hear what the story is about. A box contains 140 dimes and nickels. That's nice. And the total value of it is $11.15. That's not very, very nice. That's not a lot of money. I'm just kidding. And how many dimes and nickels are there? So I read the problem, and all I got here is that is a problem about money, okay? And then I'm going to read it for the second time, and I will pay more attention to the question now. So it does have 140 dimes and nickels. That's the number of coins. And then the total value is $11.15. So we're given the value of the coins. And the question is asking how many dimes and nickels are there. So I am going to start solving my problem from the question asked, because that's how I made a decision about assigning the variable. So I have to find two things, the number of dimes and the number of nickels. So I'm going to let D be the number of dimes. And then I would let N be the number of nickels. We have started to forget about what they look like, right? Okay, they still exist though. So now that we have a variable for each unknown, then we can convert our statements or words into equations. So again, I'm going to read the problem. Guess what, for the third time, but that's okay. That's the way it goes. So a box says 140 dimes and nickels, and you've probably figured out how to write the equation here. So you're going to say nickels plus dimes equals 140. That's just the number of it. Now we're going to we're going to work with the total value. Now we do remember that 1 dime is 10 cents or $0.1. So you can use either or. And a nickel is 5 cents or $0.05. Okay? So now we're thinking, do we use dollars or do we use cents in our equation? So I am thinking, well, here I'm given the amount of money in dollars combined with nickels, but I would say in dollars because we do have a whole amount of dollars here. So I am going to stick with the dollar value of nickels and dimes. So if you have D dimes worth $0.1 each, that means that the value of the dimes will be 0.1 times D. And if you have N nickels of $0.05 each, then you're going to say that we have $0.05 N dollars just from the nickels. And the total value will be $11.15. Now, I see that in some cute responses or solutions, people tend to do this. I'll show you what I mean. They write the dollar sign right in the equation. Now, is this a good idea? Is this right or is this wrong? I wouldn't say it's wrong, but I wouldn't say that it's the best idea either, because we already have variables in here, N and D letters, so we don't want to add extra symbols in an equation because it makes the equation more awkward. So please try to avoid or using such symbols in the equation. And now we're going to solve the system. Obviously in here we can use either method, substitution, elimination. It doesn't really matter. But because we are doing word problems and we already use the elimination method, I am going to go for the substitution method. It seems a little bit more feasible in this case because we have both variables N and D, very easy to isolate. And if you use elimination, you would have had to change these coefficients, and these coefficients here that you want to match them with are kind of decimals. So let's go for substitution method this time. So if I use the substitution method, then I am going to work with one equation at a time. So I will write in here N plus D equals 140, which makes D equal to, or N equals, it doesn't really matter, 140 minus D. And once I'm done with equation 1, then I will move on to equation 2. And instead of N there, I'm going to write 140 minus D, which is the equivalent value of N. And then plus 0.1 D equals 11.15. So again, don't forget, when you are expanding here, you have to do it carefully. So you have a binomial there. So 0.05 times 140, that would be 0.5 times 14, or 5 times 1.4. So that would be 7. And then minus 0.05 D plus 0.1 D equals $11.15. And then negative 0.05 D and 0.1 D are like terms, so we'll add them together, and that will give 0.05 D positives. And on the right side, we're going to have just the constant numbers minus 7 here. Sorry, I made a mistake. 4.15 minus 7. And divide both sides by 0.05. And we'll have the value of D equal to 1115 minus 7 is 4.15. And that divided by 0.05, it's the same as if you are dividing 415 by 5, okay? And then 415 by 5 is equal to, 5 goes into 48 times, and then 0 times into, and then 3. So I think that would be 3, okay? 5 times 3, 15, 5 times 8, 40, yeah, 83. So there are 83 dimes in there. So if there are 83 dimes, that means that if there are 83 dimes, then that means the number of nickels would be 140 minus 83. And that will amount to 60 minus 57 nickels. So the final statement here would be there are 83 dimes and 57 nickels. All right, hope this made sense. And we are going to move on to the last set of problems, but I will record it in a different video.